Hello everyone, this is Rohan and welcome to my channel. Today I will do two very well-known classic machine learning algorithm which is grid search CV and random search CV from scratch. So this will be three series of video. The first one I will discuss why exactly we need cross validation dataset in any machine learning training, and the next one will be grid search CV implementation from scratch with pure Python, and the third one will be random search CV implementation from scratch. So the basic question you may ask that why implementation from scratch, because they are already very well implemented and optimized in a scikit-learn library. So the main reason is that as a data scientist in any world-class position in your career, you many times have to implement many algorithms from scratch, especially while you are implementing from research papers, because many times the existing libraries will not cover the new proposed methods or algorithms in the research papers, and that's when you need to the skill to implement machine learning algorithm from scratch. Especially doing any kind of competition like kaggle, etc., you need these skill extensively. And so one of the focus of my YouTube channel will be implementation of many machine learning algorithm from scratch, both classical and the deep learning portion. So before we go ahead, a quick word on my YouTube channel that I plan to upload videos quite frequently, 2 times through 3 times each week. So if you have not subscribed yet, please do subscribe, and if you like the video at the end, please hit the like button. Alright, with that introduction, let's jump in. Alright, this is the first video on the series on making grid search CV and random search CV from scratch. And in this video, I will be discussing that why we need a KFold cross validation on a dataset at all. So let's start, and for our for simplicity, for the entire example of this video, we will be using the algorithm of KNN, or K nearest neighbor, where the goal is to find the best K to train our entire data set, and K can be number 1, 2, 3, 4 up to 10, or even sometime even more. So let's take an example of a example data set. This is our example dataset DN, and normally we divide it into 3 parts: train, test, and CV. And that is a cross validation. So for example, let's say our train is 60%, test is 20%, and cross validation data is 20%. And then our machine learning model or algorithm, for example, in this case KNN, will be training on the 60% of data, and then it will achieve a result, and that trained model will be applied on the test data set to calculate the accuracy. So this is the fundamental way it will work. Now, the problem with this approach is that we are using only 60% of the whole data set for our training, and that's a big disadvantage, because by the general theory that more the data, more better is my training accuracy of our machine learning model. So when I'm training only on 60% of data, I'm losing quite a bit of data which could be used to improve my model. So then the fundamental question comes: can we increase my training data set so that the corpus, the pool of the training data set increases, and so the accuracy of my machine learning model will improve as well? And that's where KFold cross validation concept comes to help. And remember another point, that I cannot just use the test dataset 20% for my training, because test should be completely unseen and unknown, and in no way the test, any of the samples from test can come into my training, because in that case the whole concept of training will break down. So yeah, so that's a problem here, and this is a problem that KFold cross validation solves. But before going into the KFold, quickly check out how these my K nearest neighbor model works. So in K nearest neighbor, normally I have a graph like this. So on the horizontal x-axis, I have K of 1, 2, 3, 4, and so on up to say 10. And on the y-axis I will have the accuracy. This is accuracy. So for each of k1 I will get a particular accuracy score during my k-nearest neighbor. So for example, say for 1 I get an accuracy score here. For k equal to 2 I get an accuracy score, for example, say here. K equal to 3 I get a slightly better accuracy, say here. And k equal to 4 say I get accuracy of here. And k equal to 5 I get an accuracy somewhere here, here. So my k nearest neighbor curve then will look like this. And just because for k equal to 4 I got this highest accuracy point here, so that will be the k, the optimal value of k that I will be using for a k nearest neighbor training. And so this is the way that normally without using grid search CV for a single training I use k nearest neighbor. And now we will see that how cross validation will come into play for exactly this kind of calculation. So I come back to my original data set, dn, and let's break this data dn into two parts, test and train. So here is my d train. Let's give it 80% of the data sample, and here is my d test. Let's give it 20% of the data sample. And again, remember that d test should always be completely unseen. It cannot any samples from d test cannot leak into my d train. So d test I will never touch. I will only after my training is done, I will only apply the trained model to calculate the accuracy from d test. But during the training, I will completely forget about this d test part. So this is unseen. Sorry. And now I take only the d-train part. So this is step 1. And in step 2, I take only the d-train part and break it down into, let's say, 4 different segments equally. So that will be my d1, d2, d3, and d4. Okay, my drawing was not perfect. These are all, each segment is just equal 4 parts divided. That's the first step of KFold cross validation. And now what I do is I start training the KNN algorithm on these d1, d2, d3, d4 like this. So say first I draw a grid, and first train for k equal to 1. And just again, remember the ultimate objective of these is something like this. That is the way that KNN works. On the horizontal axis, I will have the k values 1, 2, 3, 10, and on the vertical axis, I will have the accuracy value. And for each k, I will get an accuracy, and whichever k will give me the best accuracy or the highest accuracy, that's that's a k that I'm looking for. That's a whole objective of these model training, KNN. So that's what I start. So I first take k equal to 1, and then I from d1, d2, d3, I only take the first 3, d1, d2, and d3, and train the KNN on them. And for the accuracy calculation, as per this graph, I take d4. That is a leftover, the other segment of the whole data set. So again, these whole accuracy calculation here, it's done on the cross-validation set. This is a cross-validation column, and these accuracy calculation is done on the cross-validation set only. I am not, remember again, the most importantly, I am not looking at the test data set at all. Test data set is completely set aside. What I'm doing currently is only training on D1, D2, D3, and then calculating the accuracy on D4. And then in the next step, so that's my one step or one calculation. Then I do exactly the same step for k equal to 1, but this time I train the data on D2, D3, D4, and for cross validation, that is for accuracy calculation, I apply this on D1. So you see the point that I'm gradually just leaving out one data set out of the 4 for cross validation calculation, but for the training I am taking the rest 3. So initially I did these for D1, D2, D3 and calculated cross validation on D4. In the next step I trained the model on D2, D3, D4 and calculated cross validation on D1, and then in the next step again k equal to 1, I do this for, let's say, D3, D1, D4, and what is left, D2 for cross validation calculation. So, and again I get a accuracy score based on this graph. And similarly the last one would be for k equal to 1, the last one would be D2, D1 and D4 for my training, and I check the accuracy on the dataset of D3. And let's say the accuracy for the first one, the first training, where I am checking the accuracy on the D4 dataset is A1, accuracy here is A2, here A3, and here A4. Okay, so now again, the benefit of this is that in the original data set, that is when I divided this whole data set, I do not have any cross validation here. I just just split the whole data set dn into train and test. So there is no cross validation. So I got the entire 80% of the training data set. So the training pool actually increased. But during the training, I have a cross validation split from these D1, D2, D3, D4 like this. So in this way, I have actually increased my pool of training data set, and I'm getting 4 cross validation accuracy, A1, A2, A3, A4. So, and all them for k equal to 1. So what will be my accuracy for this training, the whole training, that is for k equal to 1, that is just the average of this A1, A2, A3, A4. Let's say that is A1 average. Similarly, exactly in the similar way, I have to do for k equal to 2, k equal to 3. And exactly in the similar way, I have to repeat the same for k equal to 2. K equal to 2, first I take, for example, D1, D2, D3 as my training set. And for cross validation, I set aside D4. So similarly for the next one, for the cross validation, I set aside D3, D2, and the last one is D1. So in this case, it will be D1, D2, and D4 for training the KNN, and then here it will be D1, D3, D4, and last one is D2, D3, and D4. K equal to 3. So note that for each value of k, I'm repeating these 4 times, because I have split my data set into 4. So that's the main point in KFold cross validation. And yes, I did not write the accuracy. So for example, for this training, my accuracy is say A2. All right, let's name it something like A1, A2, A3, and A4. And the accuracy, the overall accuracy for this training will be the average of these four numbers, just like the previous case. So the main point to note here is that I'm not wasting any part of my training data set. So going back to our previous this slide, that I initially, when I was given a dataset dn, I split it in dtrains 80%, dtest 20%, and now during the KFold cross validation, I am making use of the entire 80% of the training dataset. For example, let's say D1. Let me change the color. D1 was used 3 times during the training. D1 here, D1 here, and D1 here. It was used 3 times during the training. And for the cross validation, it was used here. Similarly for D4. D4 was used 3 times here, here, and here during the training, and it was used for cross validation here for once. So this is exactly, it's happening like this, that each part of the data set is being trained 3 times, and this is also used at least once for the cross validation. So that way there is no wastage of the training dataset at all. The whole pool is being cycled and cycled again and again to get my training and accuracy. So that's like the biggest, smartest way of gaining the advantage of not missing any data for my training. Oops, I just made a quick mistake here. Here it will not be 3, it's 2, because in this training I'm training all of them to be k equal to 2, because the training for k equal to 3 will be the next step. This is not in this step, so this was a mistake. Sorry about that. It is 2. It is 2. So for all this training, I'm using exactly the k equal to 2, but for k equal to 2, I am using the different parts of the data set for train and for cross validation. So all of them are k equal to 2. All right. So this is in gist the KFold cross validation, and for our case, the original data set was split into the 4 parts: D1, D2, D3, D4. So these process, number 1, number 2, it will go on just 4 times. That is, the next one will be for k equal to 3, and the last one will be for k equal to 4. And in this case, it's called 4-fold cross validation. So the KFold cross validation, the K stands for the number of cross validation you run, and that's a way, and that actually denotes that how many split the original data set was splitted into. So in this case, the original data set was split into 4 separate set, so it will become 4-fold cross validation. And then after this training, let's say for these I get a accuracy average of, say here something like accuracy says something like 85% here. And for our previous one, say this average, they say we got 82% accuracy. So whichever gives the maximum accuracy. So for k equal to 1, I got 82% accuracy, this average value of A1, A2, A3, A4. And then for k equal to 2, I got, just for examples, let's say I got 85% accuracy, which is the average of A1, A2, A3, A4 here. So similarly, I will get an average accuracy for k equal to 3 and an average accuracy also for k equal to 4. And then the highest accuracy, whatever it will be, say for example, for k equal to 3, for the same calculation, I get an accuracy of 96%. So that means that's the highest accuracy I got. So that means k equal to 3 will be my final optimal value of the KNN classification model, that KNN algorithm that I was running for this data set. And this is the final outcome of this KFold cross validation, that it will give me the optimal hyperparameter to choose for a model. So for KNN model, KNN algorithm of machine learning, K is a hyperparameter. That what is the K value of K I should choose for optimum result, for maximum accuracy, or whatever the evaluation criteria. And in this case, whichever K gives me this highest accuracy, that will be my result or output of this whole KFold cross validation technique. So ultimately the question is, so what's the purpose, what's the main benefit of this KFold cross validation? What, after I got this K equal to 3 as the optimal, so what's the significance of this? So the significance is, now given a query point, say for example xq, when I have to run a model for getting the prediction on xq query point, I will use this K equal to 3 as the hyperparameter value for applying KNN on these xq. So definitely when given a query point, after this KFold cross validation is done and I have received the K equal to 3 as a most optimal value from this KFold cross validation, and now given a query point xq, I will train the KNN on this entire G-trend, but now I know that when I apply KNN on this entire G-trend, I have to make use of K equal to 3, because that's where the accuracy is most, or the optimal, because I know it from running KFold cross validation previously. And note again the most important part, that these d-test, this 20% value, it still remained completely untouched and completely unseen for the model, because throughout this entire KFold cross validation that we ran, all this calculation, we have never made use of the test. That was completely separated out. All we did, we just split the original data into 80% and 20%, and then from this 80% we made a split of D1, D2, D3, D4, and from this split we made different sets of cross validation. First D1 is a cross validation, then D2 was a cross validation, then D3, and last D4. So all the cross validation was generated from these 80% itself. We never touched during the cross validation process, during the KFold cross validation process, we never touched d-test. So d-test remain completely unseen for the model, and which is what is most important when calculating my accuracy on d-test. Now, the next question which will naturally come to mind, that when I'm running this KFold cross validation, that is KFold means that how many split I make on the trained data set, that in this case I made a split of 4. So what's the optimal number of this K, of this number, that how many split the data set, the original 80% trained data set should go through? And the answer of that question is that there is really no absolutely foolproof and robust scientific or mathematical paper on what the optimum, how to calculate the optimal K. Normally, for most of machine learning model, we use K equal to 10. That is, we split the training data set into 10 different parts. So we can of course use 4, 5, 6, or even 100. But this number 10 is the most commonly used rule of thumb number that we apply to KFold cross validation. That is, we split the dataset or divide the training dataset into 10 different parts. And now the final point on KFold cross validation, and which is its one little drawback. And that drawback is that the time it takes for KFold cross validation is actually K times of a normal process. Let's see why. Because we are dividing our dataset into 4 parts. In our case, it's a 4-fold cross validation. So these calculations of calculating the accuracy happens 4 times. One for this dataset, that is D1, D2, D3, and putting D4 as cross-validated data, and then cycling through D1, D2, D3 as the CV data. and then again we have to do the same calculation for the next value of the hyperparameter k. And similarly, we also have to do k equal to 3 and k equal to 4 because we have 4-fold cross validation here. So just imagine if we had 10-fold cross validation here, that is instead of splitting our data into 4 different parts, if we split into 10 different parts, then the same calculation will go on for 10 times. That is, instead of d2, d1, d4 here, we will have d2, d1, d4, d5, 6, 7, 8, 9, and just one of the data set will be the cross validation. Similarly, for this cell as well, all the 9 parts will be here for training, and 1 part will be in the cross validation here. And so the total training time will increase by k times for a KFold cross validation. So this is the only drawback, while using it, and especially this is more prominent while using it on large data set, and that's why for large data set we use slightly within KFold cross validation we use slightly more optimized one or more efficient one, which is random search CV. But that's that I will discuss in the next video. So for now, this is all about this video. Thank you very much for watching, and once again, I plan to upload videos quite frequently to my YouTube channel. So if you have not subscribed yet, please do subscribe, and if you like the video at the end, please hit the like button. Thank you very much.